Right, here we are on page 4 in 2.1. This has been a heavy-duty section because we're trying to just get our steps totally set and ready to go as we move through chapter 2. The other sections in chapter 2 will not be as heavy because we'll have all our steps ready to go. We'll just be facing new looking equations, but our steps won't change. So absorbing 2.1 is the heftiest part of this beginning part of chapter 2, these first few sections. So solve each equation using the addition property of equality. That is the same instructions we've had all along. We are just gradually increasing the challenge of the equations. And in this case, we brought in fractions. So as you look at it and go, oh, you should notice right away what's causing you to hesitate, and that's the fact that fractions are involved. I'm hoping some of you are at the point where you are getting your confidence in fractions. It's like, no fear, bring it on, I can do this. Trust the steps, knowing that we'll do the same thing we've done all along in this section, just now that when we're undoing what's happening to the variable, it will involve adding, subtracting fractions, okay? And I'll trust, I'm not going to teach how to do that in this section. I'm just going to go through the process, and if any part is iffy for you, please ask, bring it to class, take it to your help resource. Okay, so let's go through these problems. The goal is always the same. Our goal is to get t by itself, our variable all alone. We're going to first check for, are there any parentheses? Is there anything that we need to distribute? In this case, there's no parentheses. That's been done for us. We check for like terms because we're trying to simplify right now. And there's no like terms on the left side. There's no like terms on the right side, so that's been done for us as well. We check that t is on one side or the other, but not both, and that it's not in more than one place. So t is in one spot, and in fact it's on the left side, and there's only one of them, so we are fine. That's also been done for us. So even though there's fractions, it's the drive-through version of fractions. We are ready to jump in and solve it. So we start by asking what's happening to t. So in this case, what is happening to t? And in this case, the first thing that's happening is, again, ignore what's on the other side of the equal sign and say if we put in a number for t, what would we have to do? Well, we'd have to add 2/3. So we're back to just that one step. It was kind of exciting to have 2 steps there in the other problem. Just planting a seed there in the last video. We're going to add 2/3 to both sides, or you could write this very visually here. You start with t, and then we're going to add 2/3. Kind of looks like we just copied the equation. What are we doing here? We copied the left side. We're not. When there's more involved, it won't be just like copying. You'll see that in the next equation, and we saw it on the previous video, on the previous page. Once we have our list or our visual version here, by the way, the visual version, you're going to read it left to right, t, and then you add 2/3. We're going to now create the undo. We're now creating the prescription how to solve this situation, right? You go to the doctor, you're sick, he writes down a prescription, he tells you what to do. Here, take this medicine twice a day at such and such a time with food, and then make sure you're getting 8 hours of sleep a night. You then go home and follow that list of directions, okay? You don't wonder why anymore. You don't ask yourself, well, maybe I should try this or do something different. You took the time to go to the doctor, pay the money to see him, to get his or her advice. Now you're going to go home and follow that advice. So it's kind of like you're writing a prescription for yourself right now. Go up the list, backwards through the list. One step is not very exciting going backwards. It's still just one step. But you do get to make everything opposite. So now you're going to be subtracting 2/3. On the visual timeline here, instead of going to the left, we're going to go from the right, or going from the left, we're going to go from the right. We're going to head right to left. And every time we hit something, we're going to do the opposite. So minus 2/3. And then we're going to follow that direction back. So, we've told ourselves what to do now. So we're going to follow orders. We're going to follow the prescription. We're going to subtract 2/3 from both sides. And that gives us t, bring that t straight down, bring the equal sign straight down. The 2/3 goes away. Negative 7/6 minus 2/3 is going to be a negative 11/6. I'll show you real quickly why here, because I'm doing negative 7/6 plus a negative 2/3. That's what minus is. I change the 2/3 to -4, 6, so I have matching denominators, and then I add -7 and -4 to get the -11. So that's where that came from. If you need more help, please get to me or another resource that can help you get better at fractions. Practice is going to make it better once you understand the main concept of like denominators. When to use them, how to do it. So I've got an answer, t's by itself. I've reached my goal. We need to check it back in the original equation here. So t plus 2/3, will that get me my -7/6? If I take my answer and plug it in, will it get me what I expect? -11/6. Again, I get to do common denominators here. 2/3 will become 4/6. So I'm adding -11 plus 4. That does give me -7/6. So it does check. I have a true statement here. And I don't want to run into my other workspace, so I'm going to jump right above here and put my set notation, my answer, -11/6. If you wanted to write that as -1 and 5/6, that would be fine too. Okay. If the book leaves it in improper, you're okay to leave it improper. If you wrote it as -1 and 5/6, you turn to the back of the book and see -11/6, don't panic. Just go, oh, no, that's okay. I've got the mixed number version of that. I'm okay. All right. Let's try number 38 here. And again, fractions, but we're just going to trust the steps here. We're going to check for parentheses. There aren't any. It's been done for us. We're going to check for like terms. We look on one side or the other. There aren't like terms to combine on either side of the equal sign. And we make sure Z has picked a side. We've just got Z on one side, and we do. It's the right side this time. A little bit, shaking it up a little bit. Okay. Next, we're going to ask ourselves what's happening to Z. So just look on the side where Z is. And you say, okay, if we put a number in for Z, what would happen next? Well, after you put in a number for Z, you would add -5/2. Or you could think of that as just subtracting 5/2. Either one is fine. You could also show this in visual form by saying you take Z and then you subtract 5/2. Okay? Or you add a -5/2, whichever makes more sense to you. Again, we're describing it from left to right here. You have a Z, here's what you do next, here's what you do next, that kind of thing. So then as we would create our undo list, we would go up the numbered list and create everything to be opposite. So if you were thinking of it as add -5/2, you would now subtract -5/2. If you were thinking of it as subtracting 5/2, you'd now think add +5/2, because that's what subtracting a negative is. So either way, you're going to be adding 5/2. If you go right to left now through this more visual version of it, you would do the opposite of what you see, and that's to add 5/2. So subtracting a negative is the same as adding that positive here. So we're going to add 5/2 to both sides. I apologize for kind of running into my other problem here. I'll start kind of scooting everything. We'll drop it down diagonal this time, give myself a little bit more room. So I still have the Z, the -5/2 and +5/2 wipe each other out. That was the whole point. 7/3 plus 5/2. You're going to end up with 29/6 on that one. Here's what happened with the fractions. Okay, I've got 7/3 plus 5/2. I need to change those to common denominators. 6 would be that common denominator. I would get 14/6 plus, 15/6, and that gives me 29/6. So our final answer, oh, I don't need the plus, sorry about that, because Z's all by itself. Our final answer is Z equals 29/6. I'm going to take a moment to check that. And I go back to my original equation, 7/3 equals -5/2 plus Z. If I put in my answer there, will it equal? Will it make the original equation true? So 29/6. Do a little fraction work here. Get common denominators. -5/2 is going to become -15/6. And then when you add the 29/6 to it, you end up with 14/6. And we're just wondering, are those equal? Yes, that reduces to 7/3, equal to 7/3. And then that's a true statement. And so I get to put it in set notation. my answer of 29/6. Or you could put that in as 4 and 5/6. Okay. All right. So now we're going to move to the next video, and if you kind of look down at the bottom of your page, I rewrite this exact same equations again, but we're going to do them a different way this time. For some of you, that fraction stuff is just going to be exhausting. By the way, we're in chapter 2. We're preparing for the next test. This test does allow calculators. Okay, so at least you have that going for you. You can breathe easy a little bit. We're going to look at this tip starting in the next video. When there's an equal sign, you can eliminate the fractions. You don't even have to bother with the fractions. You can eliminate them, okay? How do you do that? What's the big secret? Now this is only when there's an equal sign, okay? If it's just an expression you're having to add or subtract or multiply and divide, you can't get rid of the fractions. You just have to deal with it. Sometimes you just have to deal with life, right? But sometimes there's a way to avoid the issues. Sometimes you can work around it. If there's an equal sign, you have a green light to eliminate the fractions. So how do I do that?